For those of you who haven't yet met, my name's Tom Holmes. I've set up my own consulting business, Tom Holmes Consulting, in September of last year. But having spent most of my career, over 20 years, working for one of the major manufacturers and distributors, and I'm actually a former president of the BPCA, which means that the association is pretty close to my heart. But so delighted to be here. I'm going to be talking through the good and the bad, possibly, that comes with the move to LED insect light traps, and hopefully getting into dispensing some of the myths that we hear and really getting to the facts of where we are as an industry. Let's jump straight into it. First of all, insect light traps. Let's start with the naming convention, because I refer to these devices as insect light traps, but there are plenty of different terms that different manufacturers, users use. So whether that's fly killers, EFKs, electric fly killers, fly lights tends to be more of an American term. Insect light traps, ILTs, the abbreviated form, fly machines, fly traps. I've heard all of these names, and each to their own fundamentally. But I tend to use the words insect light traps, so that's what I'm going to be using throughout these few slides here. So what do we mean when we talk about ILTs? These are some examples of various ILTs available in the market right now. So different shapes, different sizes, doing things in slightly different ways, different UV lamps, UV sources, as we'll come on to, but fundamentally looking to do the same thing, which is manage flying insect activity within an application. And I should say thank you to the manufacturers here who have allowed me to use their images of their products in. So how do ILTs work? Let's talk about the basics. There's fundamentally two different approaches. The one that is perhaps rightly more popular now, we might be more familiar with, is the slightly newer approach, glue board insect light traps. So these devices all do fundamentally the same thing. They have a UV source, be that a fluorescent lamp or a LED UV source to attract flying insects to the device. And then they have a sticky glue board, which the insects get caught on, which of course allows us to monitor and then analyze that insect activity, count the number of insects, maybe identify the species on them. So it's a really fundamental and useful tool for flying insect monitoring. The other slightly older approach, but still has its uses, is the killing grid insect light traps. So these are the devices that, again, have a UV source, a fluorescent lamp or an LED UV source that attracts the insects, but the insects then get zapped on an electrified killing grid and fall into a catch tray at the bottom of the unit. And these are useful tools, typically now for non-sensitive applications, back of house, warehouses, but allow for high infestation sites to help us manage the insect population. So those devices that we're talking about, ILTs, as I call them, between glue board and killing grid devices. But what is ultraviolet? We keep hearing about this term. It's the UV that attracts the flying insects, but what is it and how does it do that? I'm not going to dive too heavily into the science behind it, but we need to have a quick look here at what we call the light spectrum. So this shows the range of wavelengths of light that are all around us. Our human eyes aren't particularly sophisticated, and we can only pick up wavelength between 400 and just under 800 nanometers. Nanometers is a tiny measurement, a unit of measurement. It's a millionth of a millimeter, but those wavelengths of light that we as humans can see are the colors, of course, everything from blues to greens, yellows, etc. And that's what we can see. What our eyes can't pick up is the two ends of that light spectrum. Humans can't see infrared, so we've got over here, but we also can't see this area here to the left with the lower wavelengths, the ultraviolet spectrum, and that's the bit we're going to utilize to attract flying insects. So if we have a closer look at the ultraviolet spectrum, we've got on the left here UVC, which is sometimes referred to as germicidal. That's the UV that helps sterilize, break down bacteria, used in food production to prolong the life of food produce, but also to clean water, to clean air, to sterilize. UVB, that's typically used historically for sunbeds before they became less popular, but sunbeds may be a little bit of curing of materials. But what we're interested in is this area here, UVA. That's the spectrum of light that we know attracts most, not all, but most species of flying insects. So That's where what the UV is. Why are insects attracted to it? But the truth is we don't know. But we're pretty certain it's to do with that the necessity for flying insects. They rely upon the sun. So a couple of theories is that UV, if we put a UV lamp in an ILT out in the marketplace, the insects see the UV, think it's the sun, and they're naturally attracted to that for the heat that they need to survive. One of the theory is that in nature, as the sun sets, it then provides on a horizon, it provides horizontal lines that help the insect orientate itself to fly the right way up, fly in the direction they want to go. So various scientific papers trying to prove this point, but the truth is we don't really know. But the purpose is this: UV attracts most species of flying insects. Let's stick with that. Let's deal with the big myth, the big rhetoric that I keep hearing across the industry, which is they're going to ban fluorescent lamps, aren't they? What are the facts around that? The truth is, here in Europe, they probably are at some point, but not for at least for 2.5 years. Let's break that down. So, again, we're not going to get too deep, but it is important we understand the context here. General purpose fluorescent lamps, so that's the sort of white lights, strip lights that you might have in your kitchen many years ago or in your offices. These general purpose fluorescent lamps were banned for sale across Europe several years ago now under what's called the Roche Directive, the restriction of hazardous substances. So this is a piece of legislation that essentially means any item that is produced and sold across the continent of Europe mustn't have above an agreed amount of 10 restricted substances. And one of those restricted substances, mercury, as we'll come on to. All fluorescent lamps have at least an element of mercury, an amount of mercury in it. So under the Roche Directive, fluorescent lamps were banned. But UV fluorescent lamps have an exemption through to February 2027. So the European Commission looked at it and said, right, when they made this decision, there weren't really any alternatives to UV fluorescent lamps as they saw it. So they excluded UV lamps from the Ross exemption, which takes us through to February 27. So what's that, 18 months away? However, the European lighting industry, and you'll recognize some of the big names that we typically use in our industry, so Philips brand, Sylvania brand, they've come together and they've asked the European Commission to look to renew that exemption for another year, for a further amount of time. And in doing so, just asking for that renewal means that the deadline is extended by 1 year, gives them more time to review it. So that means we're going to have fluorescent lamps able to be manufactured and sold across Europe, the continent of Europe, until at least February 2028. So that's 2.5 years away. And at that point, the European Commission will then decide whether they want to extend the exemption, which means they could say, yeah, we can allow you to continue to sell and use fluorescent lamps for another 1 year, 3 year, up to a maximum of 5 years. Or they could turn around and say, no, there's alternatives now, probably LEDs. We don't need to continue to use fluorescent lamps. So that's the guts of it. We've got fluorescent lamps for at least another 2.5 years. Then we may get a renewal. So within that context, I think we're all starting to see the transition to LED lamp insect light traps from the leading manufacturers. And there's no doubt there are some huge benefits to that. So we're going to have a look at the benefits now of LED technology. And then I'm going to roll and mischievously ask a couple of questions that means that it could be some challenges that come with those benefits. But let's start with the benefits. And there's 3 fundamental benefits I want us to talk about. So first of all, reduced running cost. And this is a biggie. So particularly for the end users, so as a service company, as a PCO, if I'm either leasing or selling the insect light trap to one of my clients, one of my customers, an end user, they're paying to run that insect light trap. They're paying for the electricity required to keep that insect light trap running effectively. We're going to have to do a little bit of maths here, so bear with us. I'll try and walk us through it. But this is a really important point in terms of how we confirm the reduced running costs of this insect light trap. So first of all, we've got on the left here a traditional style fluorescent lamp insect light trap, and I picked a 30-watt model, of which is the most common on the marketplace. That has 2 15-watt, 18-inch fluorescent lamps in it. And what you'll find if you look somewhere on those insect light traps, there'll be a specification label, a rating plate that has a number on it of the amount of watts, the amount of power that unit draws to run the insect light trap. Typically for a 30-watt traditional fluorescent lamp unit, it's around about 36 watts. Historically, if I'm honest, we tend not to pay too much attention to it, but it's there in writing on the unit that you already got out of the field. What we're seeing now is with the move to LED lamp technology, that insect light traps are coming to the market with a significantly lower power draw. So I've taken an example of one here that claims to draw 14 watts of power. So you can see a significant drop in the power draw requirements there. Now, to do this calculation, we need to convert that into what are called kilowatts. So that's 1,000th of a watt. So you can see here for my 36 watts, I've now got 0.036 kilowatts. Again, for the LED version, 0.014 kilowatts. Then we need to know the cost of electricity. And it's, with everything that's been going on globally over the last couple of years, electricity prices here in the UK pretty much as expensive as it ever be. So I've taken an average here of about 30 pence. You can look into what the price is used in each particular facility. But if we assume 30 pence, that's how much we're paying for each kilowatt hour of electricity. And finally, we've got to think about how often is this insect light trap used? Now, best practice I would always advocate is that the light traps are left on 24/7. So 24 hours, 7 days a week, 365 days a year to ensure we're managing flying insect activity. And that equates to 8,760 hours that the unit's going to be used every year. And then we essentially take these three numbers, bottom number in brackets, plus the electricity cost, times it by the number of hours we've got it in use. And that gives us our annual running cost for the insect light trap. That's how much it should in theory cost for us to run that product. And this is where you can start to see a difference. So for a fluorescent lamp model, it's just under £100 to run that for a year. For a LED lamp model, it's around about £37 with my example here of 14 watts. So that means there's a saving. We take away this one from this one. If we replace this fluorescent lamp model with an LED lamp model, we're saving £58 a year on that model. £58, nice to have. Is it going to change our world? Possibly not. But let's start to think about some of the medium to larger sites. If we've got one insect light trap, yep, we're saving £58. If our users got 10, they'd be saving £580 a year. If they've got 50, getting into larger food producing sites now, just under 3,000. And then where it gets really interesting, if you start to think about, let's say, a major supermarket brand that here in the UK might have 5,000 insect light traps across all of their sites, they're saving £290,000 a year. And that's what gets really exciting for those end users. So I've talked through a bit of detail there because we have to understand these fundamentals, because you'll see that all of the manufacturers make certain claims about savings and what percentage of savings. You need to be clear on how they work that out. And if needs be, challenge them on that data. So number one, reduced running cost, a real benefit for those end users. Then we've got the improved sustainability. In these times, we absolutely need to have our finger on the pulse of this. How do we get improved sustainability? There is absolutely lower power draw. We've just talked about that. We're using yet less electricity. So all the natural resources required to create that electricity, if it's using fossil fuels, the CO2 that's created, we're using less electricity to run these ILTs. We touched on this earlier, but we've got no mercury in LED lamps, whereas the fluorescent lamps all of them have an amount of mercury in them, which can get into the water systems and be a real hazard to aquatic life. And also we're getting up to 3 years life out of these LED lamps. So many of you will recall that typically fluorescent lamps, we tend to service once a year. They last 1 year, need replacing every 12 months. The LED lamps that I'm seeing on the marketplace now, manufacturers are claiming up to 3-year life, which means there's less items being physically produced, manufactured, creating less CO2 using electricity. And then there's less physical items that we're shipping across the globe. We're having to put in the back of our vans to take out to our suppliers. So we're reducing the amount of emissions put out through the use of these. This is all top level, but hopefully gives you a steer on this case, improved sustainability. Thirdly, we've got future proofing. Now, we talked earlier about the facts of the matter is it's going to be a ban overnight, but my personal view is there will be a point in the future where we're no longer allowed to use fluorescent lamps across the continent of Europe. So we need really to start to plan for that. So as we said, fluorescent lamps are likely to be available through to at least February 2028, but then we don't know. So to future-proof us, we've got to think about the implications of fluorescent lamps. So fluorescent lamps, a few years ago, the manufacturers were producing billions of lamps, both general purpose white lights and UV fluorescent lamps. Now they're producing just a decreasing number of fluorescent UV lamps. So their costs are going up. They're producing less quantity. They're buying less of all the component parts, the end caps, the glass tubes. So their costs are starting to go up. So it is likely, therefore, that over time we will see an increase in the cost of fluorescent lamps. But also, there's a real possibility that we will face supply challenges in terms of the manufacturers of these lamps. Where do they get their components parts from? I know of one major manufacturer last year was really struggling to get hold of the glass tubes that all fluorescent lamps are made from. So there could be disruption to supply. And with that comes the availability to us, to service companies, through both the much smaller quantity of fluorescent lamps being produced, and also over time, the demand for the market will start to go down. So there are some areas we've got to think about. How do we future-proof for areas we're using fluorescent lamps at the moment? So just to summarize the benefits, and then we'll move on to the two questions I want to ask. For benefits, number one, reduced running costs. So if we break that down, what does that mean for service companies? It's a great selling point. We can go into our customers, potential customers, and talk about significant running cost savings that those end users could experience with the move to LED. So some benefits for us and for end users there. In terms of improved sustainability, again, a great selling point for PCO service companies. And actually, I didn't mention it, but there's a lower end of life recycling cost. So as most of you will be aware, when we put fluorescent lamps and comes to the end of their life, there is a cost associated with recycling those. LED lamps have a slightly lower cost of recycling for us and the industry to pick up. And there's also a terrific end of use, improved sustainability story for those end users. And then we touched on future proofing. Moving to LEDs, it reduces the risk of obsolete equipment for us as for service companies, but also for those end users. They then want to invest hundreds, if not thousands of pounds buying products in light traps that may become obsolete in 3, 5, 10 years because of a ban to fluorescent lamps. The one caveat there is there's an interesting area of fittable lamps. That's a different subject, one we could have a talk on its own, and maybe that's for another day. But that might be as a gel-free card and how we can upgrade fluorescent lamp insect light traps to LED insect light traps. But as I said, that's one for another day. So that's all the upside. That's the good. What about the questions I think we have to ask ourselves? And the first one is a biggie. What about efficacy? Fly catch efficacy. Are the LED insect light traps catching the equivalent of, at least the equivalent of what the fluorescent lamp models are? And why is this important? Fluorescent lamps are what I call very forgiving at attracting flying insects. Put a half decent fluorescent lamp into a half decent designed insect light trap with a sticky glue board in there, and it will catch insects. We can't say the same for LED technology. LED lamps need significantly more thought because there are so many variables: the direction of the UV light, reduction in heat, the life of it, how far UV from an LED source travels versus fluorescent, the fact it's not 360 degrees in the main. These are all considerations manufacturers are having to consider. And my experience is that I have seen LED insect light traps on the market that don't catch the same amount of flying insects as traditional fluorescents, but they also don't catch the same variety of flying insect species. Let's be clear, when done well, I have seen many LED ILTs do a fantastic job, but I've also seen some stinkers. In my experience, they haven't. So we can't tarnish LED technology with not being effective, but we have to ensure that the ones we're working with do the job they're supposed to do. So that's something we've got to be really careful about. The second thing is the implication of moving to LED lamps. For decades now, we've all got used to using fluorescent lamps, and predominantly that 15-watt 18-inch T8 fluorescent lamp, the one that goes into most ILTs, whether it's a 2-tube unit or a double-sided 4-tube unit or a 3-tube unit. That 50-watt lamp will go in all of them. So I can buy that lamp from pretty much any source, and it'll work in any insect light trap in the field that takes the 50 watts. So irrespective of the brand, if I inherit a site with 50 ILTs, and some are from brand A, some are from brand B, some are from brand C, my 50-watt lamp will work in all of them. As we move to LEDs, what we're finding, for reasons I completely understand, the manufacturers are starting to develop their own UV source, different shapes, different sizes, different orientations. And that means that if we fast forward to 5-10 years' time and I inherit a site with several different units in there, I've got to find the LED UV source that fits into each individual unit. So rather than turning up to site with one 15-watt lamp that goes in all the different units, I might have to turn up to site with a handful of different styles of LED lamps, because there's different styles of LED units in the field. That's going to massively impact upon my operational efficiencies. I've got to stock more different types. That's something as an industry we've got to get our heads around. What have we covered? Where does it leave us? I believe that insect light traps remain fundamentally a essential tool for us to use to monitor flying insect activity. We talked about the fact that fluorescent lamps will be with us for at least 2.5 years until February 28, and then possibly be extended further. But there are significant benefits of moving to LED technology and to start that journey now. And we talked about the reduced running cost, we talked about improved sustainability, we talked about future proofing. But remember those two questions that I'm asking that we've got to consider. So it's not all rosy. But in summary, I believe the move to LED is a move that we've all got to take over time when it works for us. And this brings an opportunity for us, both for service companies and for end users. And that is me done. So I've raced through that.
That's all right. We have questions. That's fine.
Perfect.
So to start with, so for those who work in food factories or generally food processors, you've got your shatterproof tubes versus your non-shatterproof tubes. So for LED, are they instantly shatterproof? Do we need to make sure that they fall in line with sort of those hard plastic policies and stuff? Do you know, can you sort of go into a little bit more detail on that potentially?
Question. I would start by saying you need to speak with your supplier, because the truth is some do and some don't. So I see in the marketplace now, I see some LED lamps, LED UV sources that have no glass in them. So theoretically are immediately fine for those glass-free environments. I've seen some that are glass, still have a glass tube in them, but have the traditional FEP coating to provide glass-free / shatterproof sleeving. So it's a good question. Each case is individual. Check with your supplier.
Wonderful. And then also check with your site as well to make sure which areas are definitely deemed. Because BRC, I think, is pretty much always shatterproof everywhere, ultimately.
As a general rule of thumb, if it's sensitive to anything to do with food, processing, consumption, I would recommend shatterproof, yeah.
Wonderful. Yeah, something I noticed on the older side when sort of takeaways and stuff, they don't tend to get the shatterproof tubes in there.
Exactly. Less sensitive.
Absolutely. We have another question about how do you determine a good ILT to one which is not so good? Could be a bit of a loaded question, so I do apologize.
Yeah, I think it's a good LED compared to not so good. It's a great question, and it's a challenging one, because remember I said that our human eyes can't see UV. So we, as a human, no idea how that, with no idea how effective the UV is coming out of that. So the honest truth is your manufacturer of an LED unit would typically, they should have some form of data, whether that's lab condition trials or real world trials. But equally, there's nothing like getting them yourself, getting some samples, hands on, put them into a real environment, see how you get on. Do you think that LED unit is catching a comparable amount of insects, comparable range of species of insects to your traditional fluorescent? All I would say as a caveat to that is if you're ever doing testing, you can't put the two next to each other. Don't put a fluorescent unit right next to an LED unit and look to get a, it just won't work that way. So it may be something that, I don't know, you want to work with a consultant to help you navigate that through, but I'll leave that to you.
We have a maths question from your slide earlier. Your figure said that we would save more than £2,000 per year on 20 units at £58 per unit, but they only make it half.
I have to check my presentation. I think the third scenario I said, I may have had a typo in there, but I think I meant to show 1 unit, 10 units, 50 units. So maybe I wrote 20 instead of 50, but I'll double check the slides before we issue them. But that's the theory. But crudely, if you take the calculation we worked through, so power draw times by electricity cost times by hours of use, that gives you your saving, and then times that by the number of units that you've got in that particular site.
Oh, wonderful. Yeah. And again, it's obviously if you're selling it as well, people need to be checking their own maths as well, because it's going to vary per unit and such as well.
Yeah.
You have another question. LED UV lights tend to create less waste light in the visible spectrum. So we often get customers saying, it's not working, it's not very bright. What's the best way to communicate that to customers to say it is still working, it's still doing its job?
Yeah, it's a great question. It's a great question. Unfortunately, it is a case of talking to people and educating. And I think there's two strands for this. I think, first of all, how's that conversation with your clients, your end user, to manage their expectations, but also make sure you're promoting the story behind it. So your manufacturer, your supplier should be able to give you all the evidence to show the amount of UV coming out of those lamps and hopefully the amount of insects caught on that insect light trap. Use that, plus some of the information we've talked about today, to have that conversation with your end user to say, look, those big bright blue lamps that we so used to seeing, that blue light is doing nothing. It's not attracting the insects. It's the UV that we can't see. What the big blue light is doing is drawing extra power, which is costing you money. So we can show them the cost analysis. This is the amount you're saving, because as the question points out, we're much more focused on how we're using power to not exclusively, but mostly generate the UV that we want to attract insects. We're not using that excess power wasted on huge amounts of visible light that doesn't attract the insects, huge amounts of heat that doesn't necessarily attract the insects. So you've got to have that conversation with your end user to manage their expectations.
Yeah, no, that's great. And I think it's also important, isn't it? Because the actual glue boards are affected differently from a fluorescent tube to an LED, because the glue's slightly different from my understanding as well.
Yeah, it's another good point. So some manufacturers certainly have suggested that, because I think the reason they're thinking is because we don't have the heat that fluorescent lamp creates, the tackiness of the glue varies. So some manufacturers are saying we have a dedicated glue board for LED units and a separate one for fluorescent lamp units, which I guess it optimizes performance. It does mean that we've got, as a service company, we've got 2 glue boards we've got to manage. Others seem to be claiming actually our glue is appropriate for both our fluorescent and LED units, but it just depends on the configuration of LEDs, of UV lamps to that glue board. How close are they? Is the LEDs pointing forwards or back or up or down? Learn what your manufacturer tells you and follow their advice.
Cool. Wonderful. I think that's all of the questions. I have one though, actually. So
Go ahead.
to get UV testing done with the machines to say, have you changed your tubes and stuff? We did that as part of our sort of internal auditing process. From my understanding, that you can't do that on LED units currently.
So in terms of what was the very first part of that question?
So when we're testing UV effectiveness, we'd sometimes use a UV monitor to check it, and that would work great for fluorescent tubes. I understand, however, that we can't use that for LED tubes. Is that right, or have I missed something?
No, you are right. It's an interesting one. My personal views is, so when I was working for a large manufacturer, we had equipment that we could do full analysis of UV output, but it was lab-based because it was a fixed application. What's the distance? What's the angle? Those UV meters, handheld devices that you can use in the field, they're a useful indicator, but the trouble is, how far away do you stand? Do you point forwards, straight on? Is it an angle? Is the dust in the air? I wouldn't call them entirely scientific. They're a useful guide. But to your point, I know many of the manufacturers and distributors who offer those devices say, you know what, they're not working appropriately for the LED units. So again, check with your manufacturer, but I can completely understand why there's a problem with those devices using LED to test LED units. So yeah.
Cool. Wonderful. Thank you very much. No, thanks again for joining us. It was a really great talk. Obviously, lots of questions, and obviously appreciate you taking your time out today to talk to us. So thank you again.
Very welcome. Any further questions, do reach out to me, and I'll do my best to answer.